Lesson 4.5 is on factoring expressions. Factoring expressions basically is the opposite of distributing. So if you imagine a problem where you distributed and then we go and rewind to where we have a number outside of a set of parentheses, that's basically what's going to happen when we are factoring in this lesson. So if you look at example 1, Kiana painted a rectangular wall blue to start an ocean mural. She used 3 cans of paint, each of which covered X square meters, and a different size can that covered 12 square meters. What are possible length and height dimensions of Kiana's mural? So as we were reading that, we can be underlining or highlighting some information there. All right, so this is what we got, a length and a height. So this part we can think about though. Each of the, we had 3 cans of paint and they each cover X square meters. So 3 cans times X, 3X would be our area that we could cover with those cans of paint. This is not necessarily on this picture representing a length and width. Okay, so if that's confusing, don't worry about this picture. Just think about 3 cans of paint, X square meters for each can. That'd be 3X would be the total area that we could cover with that. And then the other part, we have a different size can covered 12 square meters. So 12 square meters, that's represented by the green. So again, if you want to look at that, you can. I would probably start over here and just think about, you know, with the 3 cans, we could cover 3X. The other one told us that we could cover 12 square meters. So 3X plus 12 would be the total area that we could cover. So what they're asking us to do is figure out possible length and height dimensions. Well, if I know my area is 3X plus 12, and this is a rectangular blue wall, it told us, then I know the area of a rectangle is length times width. Good. Okay, so 3X plus 12, area is length times width. So I'm thinking about something times something, that gives me 3X plus 12. Well, it's not quite the same as me saying my area is 16, what times what equals 16, right? A little bit different because we have a variable here. And the 3X and 12 we can't combine because they're not like terms. What we can do though is we can factor. We can look at the 3X and 12 and we can look for a common factor that they have. A number that they could both be divided by is a way of thinking about, okay? So with the 3X and 12 on the 3X, we have a 3 in front of it. So the question is, can we divide 12 by 3 evenly? The answer is yes. So what that means is both of those terms are divisible by 3. That means we can factor out a 3. So we factor out a 3. Basically, we had the 3X plus 12. I'll just write it here so you can see what's happening. We had 3X plus 12. We're factoring out a 3. And it would kind of look like this as you guys work it out. You would be thinking about 3 times what to get this 3X? Well, 3 times X equals 3X. And then you'd be thinking 3 times what to get 12? 3 times 4 equals 12. So this would be our factored form. If that's our factored form, we know length times width is how we get the area. Then we could say 3 could have been one of our dimensions, and X plus 4 could have been our other dimension. Okay, whether one's the length and one's the height, or if it's the other way around, we don't really know, but one of those would be one and one would be the other one. And a way you could check yourself on a problem like this would be to distribute. If you distribute, then you should get what we started with. 3 times x plus 3 times 4. It's 3x plus 12, and that's what we started with. So we know we factored it correctly. As long as we had the correct expression to begin with, then we should be in good shape here. So if we look at the try it, they want us to use factoring to write an expression for the length of the pool with the given width. Again, if the picture helps you, you're welcome to that. As far as I'm concerned, we don't have to use the picture. So what we're trying to do is we're trying to think about with the 4x and the 20, something that they have in common that we could factor out. So both of those are divisible by 4, and so we could factor a 4 out. If we factor a 4 out, let's see what we would be left with. Well, the first part they gave away, it would be 4 times x would give us that 4x that we had to start. And then 4 times what to get 20? And that would be 5. 4 times 5 equals 20. So 4 times the quantity x plus 5 would be factored. And then, so if you look at the picture now, if we know the one dimension was 4 meters, then this other dimension would be the x plus 5. 4 times x plus 5 is how we get that area. Length times width. So length, let's say our width is 4, then our length would be x plus 5. Or opposite, whatever the case might be. In this case, I guess we know x plus 5 is going to be bigger than should be bigger than 4, assuming x is a positive number. Another thing on this problem, some of you might have thought about the 4x and the 20, that they had a 2 in common, and that's true. I mean, we could technically factor it as 2 times the quantity 2x plus 10. The problem with that is they're telling us that one of the dimensions is 4. So length times width, one or the other of them has to be 4. So if I say it's 2 and 2x plus 10, neither of those is 4. So that doesn't work. That's why we know, even if the book didn't give us that we were just going to have an x, that's how we know 4 is going to have to be one of our dimensions of our rectangle. So if we look at example 2, Rodrigo and Jordan each factor the expression negative 2x plus negative 2x minus 6, who factored the expression correctly. So my suggestion to you guys would be, let's look at what Rodrigo did down here. So negative x minus 3 in parentheses, my suggestion would be add the opposite. And then when you distribute, you can put a 1 in front of that, so 2 times negative 1x plus 2 times negative 3, and then that would be negative 2x plus negative 6. Is that the same as negative 2x minus 6? Well, if we add the opposite, that would be exactly the same. So Rodrigo looks to be correct. It's possible they're both correct. We'll just see here. So if we look at Jordan, for Jordan, it's got it factored like this. So again, if we distribute, so we've got negative 2 times x plus negative 2 times 3 would be negative 2x plus negative 6. And that's the same thing as we just had. So that actually works as well. So both of them are correct, okay, in a rare case. They're actually both correct. And just a side note for you guys, the book doesn't mention this, but if you ever do a problem, hypothetically, where the first term is negative, usually it's going to be best for you to factor out a negative number. Okay, so if we ever see any problems where our first term is negative, factoring out a negative number is probably going to be a better choice for you. So even though on that example they had a negative coefficient on their first term, they didn't factor a negative. Oh, here we go. Here's one where our first term is negative, coincidentally. Okay, so negative 4x minus 28. Just like we've been doing, if you guys want to, you can add the opposite on that. Make it negative 4x plus negative 28. And then we're going to look what's in common, but whatever's in common, we're also going to factor out a negative besides that. So looking at the 4 and the 28, they're both divisible by 4. Technically divisible by 2, but we're going to factor as big of a number out as we can. So we're actually going to factor not only a 4, but a negative 4. I think is just going to make things easier for you, and down the line with some other stuff you'll do in math, that'll just make things a little bit easier for you as well. So now we're just going to think about what we would have left, so that if we would have distributed, then we would get, if we distribute our answer, we should be able to get what we started with. We're basically coming up with an equivalent expression, which is basically like rewinding of what you would have done in the last, some of the last sections as far as distributing goes. So negative 4 times x would be negative 4x. If you want to put a 1 in front of it, you can. You don't have to. And then we're going to look at our other part. So negative 4 times what to get negative 28? And that would be negative 4 times 7. Again, if you want to check yourself, you can actually distribute and work this out, and you should get what you started with. If not, you made a mistake. Okay, so this right here would be our answer. Now, this does say show 2 different ways to factor. I wasn't paying attention to that to start out with. So another option, rather than factoring a negative 4, we could have just factored a 4 out. Let me rewrite this so we can keep track of what's happening. If you factor a 4 out, 4 times what to get negative 4x? That would be negative x, or negative 1x. And then 4 times what to get negative 28? That would be negative 7. So that would be another option for us. Okay, so that's 2 different options technically. Something else we could do, like we mentioned earlier, you could factor out like a 2 or a negative 2. So if we factored out, let's say we factored out a negative 2. Negative 2 times what to get negative 4x would be 2x. And then negative 2 times what to get negative 28 would be 14. Okay, so that would be another option. Again, they didn't ask for that many options. I'm just showing you that as another way you could have done it. A fourth way could have been factoring out a 2 instead of a negative 2. Okay, factoring out a 1 does not count, just for the record. So example 3, they want us to use the greatest common factor to factor these expressions. So basically the difference here is that we have 3 terms instead of 2. So we have to find a common factor with all 3 of these. So we have 6. If you want to add the opposite on these, you can. 6, negative 18, and negative 12. We're basically looking at the 6, 18, and 12, not worrying about the negative part there. And probably the best way to do a problem like this is look at your smallest number. Okay, ignoring the negatives, our smallest number here is 6. Okay, what I'm going to do is think about whether these other numbers are divisible by 6, because 6 is going to be the biggest possible number that I could factor out. So is 18 divisible by 6?
Yes.
Yes. Is 12 divisible by 6?
Yes.
Good. Okay, so since all those are divisible by 6, 6 is going to be my greatest common factor. The book listed out the factors of all those and found that to be the highest common factor, greatest common factor. That's fine. But if you guys can just start with what that smallest number is, and it's got to be, that's the biggest possibility, and then work your way down from there. Okay, so if that's what we have, again, if these were, you want to look at adding the opposites, you can. If we factor a 6 out, 6 times x would give us 6x. 6 times negative 3 would give us negative 18. And 6 times negative 2y would give us negative 12y. So this would be our factored answer. That first term was positive this time, so that's why I didn't mess with factoring a negative out. We just factored out a 6 to start out with. Okay, and in order to figure out your numbers, to know, you know, the 3 and the 2, basically you're just dividing. So 18 divided by 6 is 3. 12 divided by 6 is 2. Obviously, 6 divided by 6 is 1. So you can put a 1 there if you'd like as well. That you can go through that process if that helps you to figure out what those numbers are going to be in your answer. So if we look at do you understand number 2, Susan incorrectly factored the expression below. Explain any errors Susan may have made when factoring. So again, if you want to, since they're subtracting here, if you want to add the opposite there, if that helps you to see that. And then they factored out a 3. So what we can do to check them on this is we can actually distribute here and see what we come up with. And then that's going to tell us what the mistakes might have been. Okay, so first of all, we would do 3 times 4a, then we'll do 3 times 5b, and then 3 times 3. So if you multiply this out, you would get 12a plus 15a plus 9. So we've actually got 2 problems here. One is we have plus 15a instead of minus 15a. The other one is we have plus 9 instead of plus 6 that we had to start out with. So the 2 changes we would have to make would be that the plus 5b should be a minus 5b there, and then instead of plus 3 it should have been a plus 2. So this, we should probably rewrite that as our answers because that's kind of messy, but that's what our final answer should have been after we factor. Slight mistake there, that's a B, not an A. So otherwise it matches with what I said, but I wasn't quite working that part correctly. So if we look at the do you know how, number 3, Sahil is putting together supply kits and has 36 packs of X pencils, 12 packs of Y crowns, and 24 erasers. Write an expression to show the total number of items. So expression for the total, 36 packs of X pencils, that'd be 36 times X. The crayons would be 12 times Y, and the erasers would just be 24. So that's an expression for the total number of items. And then part B, they want us to use factoring to show how many kits Sahil can make while putting every type of item in each kit. So for factoring, we're going to try to look for our greatest common factor. Again, looking at your numbers, smallest number is 12. I'm going to see whether these numbers are divisible by 12 or not. If not, I'm going to try with something lower than that. So 36 divided by 12 comes out evenly. 36 divided by 24 does as well. So 12 is going to be our greatest common factor that we can factor out here. And again, to figure out what our numbers are going to be, we had 36. So 36 divided by 12. I mean, we're thinking about 12 times what to get 36x here. So that would be 3. 12 times 3 is 36, and then we need our x also. And then 12 times what to get 12y would just be 1y or y. And then 12 times 2 equals 24. So this would be factoring, and what that means is that since we were able to factor 12 out, that means that he could make 12 identical kits. Okay, he could make 12 kits. Each of those kits would have 3X pencils and 1Y crayons and 2 erasers in them. Okay, that's not an exact number because we don't know what X and Y are equal to, but that's how that would kind of work. And then part C, find the number of each item in each kit, is what we were just mentioning there. So that would be so 3 packs of X pencils, 1 pack of Y crayons, and 2 erasers. Again, technically there are smaller factors that we could have used there. Long-term benefit for you is going to be find the biggest possible number. That's going to be something that'll help you when you're in algebra and stuff like that. So try to find the biggest possible number if you can. Okay, and then if you look at number 5, how can you use the distributive property to factor the expression 6x plus 15? So this is more so actually factoring than distributive property. It's kind of the opposite of distributing. But anyway, looking at the number, 6 is our biggest number. 15 divided by 6 is not going to come out evenly. So we'll try a smaller number. The next smallest, or the next biggest factor of 6 would be 3. 15 divided by 3 would come out evenly, so 3 would be our greatest common factor that we could factor out. When you factor that out, 3 times what to get 6x would be 2x. 3 times 2 is 6, and then the x part comes along. And then 3 times what to get 15 would be 5. So this would be our factored expression for that problem.